Hello viewers, welcome to the channel. If you work with satellite data, you know the pain of manually searching and downloading files, especially when you need images with low cloud cover. In this video, we are using Evo DAG library. Evo stands for Earth Observation Data Access Gateway. Use it for automatically find, sort and download the good quality Sentinel-2 image for any area of interest. To use this library, first we need to authenticate in Copernicus Dataspace ecosystem. Go to Copernicus Dataspace ecosystem, log in your profile. You can sign in to your account using email ID and password, or if you are a new user, you can click on the register button and then fill up the register form with the first name, last name, email ID, password and all other information, and then accept the terms and conditions and register. Once you have registered, you will have the login ID, that is email ID and password. So now let's get into the Python script. Let's set up a Conda environment using Anaconda prompt command line, and to create a new environment you have to type Conda create name and environment and click OK. So since I have already created an environment, so I'm skipping this step. I'll activate the environment. And then initialize Jupyter Notebook. Let's open the Python script for downloading Sentinel-2 data. And let's import all the necessary libraries such as OS, date, time, path lib for path and time handling, and core library, Evo Data Access Gateway from Evo DAG, and Shuttle for moving files. Next, let's set up a new path. Before that, we have to set up logging to Evo DAG, and this you can find here in API user guide configuration and in that logging. So logging is activated with setup logging method. So it is useful when there is error from the Evo DAG, and that will be displayed onto the screen. Let's define the destination folder, in this case Sentinel data saved in desktop, and it is created using .mkdir function. Let's also define temporary folder. Initially Evo DAG downloads raw file onto the system's temporary folder. Next, setting credentials or authentication. First two line use os.environ to temporarily set username and password in the Python script. So these two, username and password, are fetched from Copernicus Dataspace ecosystem email ID and password. So then we have to initialize the Evo DAG using DAG is equal to Evo Data Access Gateway. This creates an instance of the Evo DAG main class named DAG. This object will handle all communication with the satellite data catalogs. Next, we have DAG.set preferred provider. So provider here is COP data space. There are number of providers that DAG uses. So one of them is COP data space. So it will instruct the Evo DAG to use Copernicus Dataspace ecosystem as a primary source for the data search and download. Let's run the search query with DAG.search function, and this will have all the list of available images less than or equal to 20% cloud cover, and with a specific start and end date, geolocation of the area of interest. All these parameters are used for filtering the catalog of product, and the results are stored in the search result. Then to sort, select, download and move the best quality with less cloud cover Sentinel-2 image, we can list the available images less than or equal to 20% cloud cover, which is stored in the variable search underscore results from the previous line of script. Length of the search result is printed with lin function call. Then search results can be sorted with the sort function in ascending order. With less cloud cover image is the first item in the list. Then to select the best image with less cloud cover and selecting the first cleanest image in the list, we can use best product is equal to search result index 0. Index 0 is the first item in the list of images. The selected best quality image is then downloaded into system's temporary folder. Finally, we can move the zipped file from the temporary folder to destination folders, that is Sentinel data, using shuttle.move function. Let's run this code and see the results are stored in the destination folder. As you can see, there are 20 products that are available, and the first item having the less cloud cover and the last item have the highest cloud cover for the specific period of time, and the download has started. So here we are downloading the best image with the less cloud cover, that is first item in the list. The downloaded result will be saved in the destination folder, that is Sentinel data. The download is complete. Let's open the destination folder, Sentinel data. You can see the zipped file is saved here. Next video will be on unzipping file, selecting Sentinel-2 bands for processing and creating normalized difference vegetation index or NDVI using Python script. If you like this video, please subscribe. Thanks for watching. Happy mapping.